Albert Godfrind, and he's going to be showing us geographical graphs, and basically it's a graph, neat map. So with that, Albert works for Oracle. He's been with them for over 25 years. Again, one of our seasoned experts, and his interest and enthusiasm for spatial information and geographical information systems, it started in Oracle way back in 1998. So he's been around using this kind of technology for a long time. And he also was one of the authors of the first book on Oracle Spatial, called Pro Oracle Spatial, The Essential Guide to Developing Spatially Enabled Business Applications. God, that was a mouthful. Anyway, so with that, Albert, I'd like to invite you to present, and thanks in advance for what you're going to share, sir.
Okay, so let me then share my screen here. Okay, share, there we go, and let me go to this presentation. I hope everybody can see this. Everybody can hear me as well.
Yes, sir.
It looks great.
I like your hat,
I can
sir.
see your hat too.
I should have put a hat on today as well.
Yeah,
Yeah,
yes.
I need one.
I don't need that much, I'm still covered up here. So. All right, okay, so thanks for the introduction. Right. And so I'm the last speaker of the day, meaning that I'm standing between you and between, well, the next thing you want to do, which might be like lunch or dinner for me, maybe breakfast for some of you. Anyway, so let's talk about the last topic of today. So combining graphs and maps. And that actually will relate very close to what Jim Chopinski said earlier on, when he said he was interested in actually using graphs together with maps. And so let's talk about this. All right, so why do we need this? Well, graphs are good for showing relationships and how things relate to each other. And we can do, of course, all the analytics on graphs and find these things out. When it comes to showing results, we can show them this way. We have many ways of showing graphs, like hierarchical graphs and various ways of rendering them that highlight certain things. But there's one highlight that is also very useful, and that's the one that talks about showing the graph on a map. A good example is actually money fraud and money flow, Panama Papers, who paid what to whom. And here is maybe a possibility that this might be our Russian friend that Jim mentioned, and this could be, sorry about that, I didn't mean to do that. And maybe that arrow going from here all the way here means that there's been some fund transfer to Jersey, and from there transfer to Cayman Islands, etc. So we're going to show how this actually works, and it's very easy to do. Now, the data I'm using here has nothing to do with fraud detection or anything like that. It's much more mundane. It's about airports and routes, flights and airlines. The data I'm using is publicly available. It's from this website, openflights.org. You can download it. It has some 7,000 airports worldwide, 60,000 routes. Now, routes here are connections from one airport to another, operated by one particular airline. So it's not all individual flight. There are many more flights than that every day. So it's just a route. There's a route between, for example, Boston to Munich, which is operated by Lufthansa, not one operated by United, and then another one like Boston to Paris by Air France or Delta or other airlines. The routes are no longer updated since 2014, so this is a bit old, but it's still very nice to do some, analytics and interesting work and demos. The data itself looks like this. You have airports, which have names and codes and latitude and longitude, airlines, and also routes, which are, so these are the airlines, and this is a route. So a route is for an airline going from one airport to another airport. From a tabular perspective, that's how it looks like. And what you can see here is that, and the thing we actually need is that we need to have latitude, longitude as two numbers. They don't have to be called latitude and longitude. It might help being called like that, rather than X and Y or Joe and Jim. So latitude and longitude is something that makes sense. So only for the airports. Now, first of all, how do we get this data into a database? Well, it's just flat files, so we can load up many ways using SQL using SQL Developer. In this particular case, I use a tool called Spatial Studio, which actually allows me also to see the data spatially. So I'm going to connect to my Spatial Studio instance that's running right here on my Mac. And let me also kill this bar here that's bothering me. And so here's how it looks like. See, these are airports. They are worldwide airports. There are lots of them. I can click on one of the airports and find out what it is. This is well, the Scott Air Force Base, maybe something that is a bit more visible going, well, here, this should be, well, this would be JFK here, is it? Sorry, no, JFK is actually right here. That would be JFK and the details about these things. I can even show the routes as well. The routes will be lines connecting airports with each other. This is actually only showing the routes operated by United Airlines. And you can see hubs that are used on here. But this is a pure spatial perspective. What we want is do something with it at the graph level. So how is this graph going to be constructed? It's very easy. It's a simple create property graph statement. There's only one vertex table, the airports, and only one edge table, which are the routes. And the routes will have a source key, so source airport, destination airport, and all sorts of properties that are useful for analytics. But that's a very simple graph. So route, airport, airport. Creating the graph, well, we're going to use the SQL CL property graph plugin. That's what I used here. So just property graph, create property graph, exactly syntax I here. I could also use that, of course, do this using the Graph Studio. And just like Jim has shown, just taking these two tables will, the airports and routes, will automatically generate the data model, which will then bring the graph in memory. Here I'm going to use a local installation. And the first thing I need to do is to read the graph in memory. And for that, I'm going to just use a Jupyter notebook for doing it in an easy way. So first of all, I need to connect. So set up my environment, connect to my graph server. That's up and running on my laptop here. Yep. Start a session, read the graph in memory and publish it. And then check the graph as well. Let's check, do we have the right number of vertices? Yeah, so it's done. And yeah, so we will see that we have 7,000 airports, 6,000, 60,000 routes, and that's the right combination. Why do I need to do this? Why do I need to publish? Well, because when I load the graph in memory, when I say read graph by name, so read the graph in memory, that is now a private graph. And so it's actually only belonging to my particular session, which is that session here, so this Python session. But what I want to do is actually access that graph from the visualizer, the graph visualizer, or any application. And for that, I must publish it. So in other words, it becomes a public graph, and then I can use it from other applications. That doesn't mean that just anybody can access the data. Here I can, because I just connect as the same username. But if I want another username to read the same graph, then I need also to grant rights to that other user. Right, let's go back to the presentation. I can, yeah, that actually shows how I could do the same thing. So publishing the graph in plain Python, like command line Python, not just notebook, but notebook is just more comfortable, or doing it in Java. We also know that we can use the Java API to talk to the graph server. So same thing, except it's in Java. So read graph name in Java and publish. All right, so let's look at this. Let's go to our graph visualizer. That's a hard name to say. All right, so here we go to the graph visualizer. I'll log in, so as graph, username graph, password is graph as well, so not very secret. And so I'm getting this. There's the only one slide that I have, because I just loaded slide, there's nothing else. So I can click on this and then view my graph. All right, so here it is. Now this just picks 100 random airports and their connection, their implicit connections. Now let's do something here. Let's improve this by doing some simple things, like first of all, well, add the vertex label. That will be the IATA code, so the 3 letters code, like JFK for JFK, and then Nuke for Munich, CDG for CDG airport. And for the edges, well, I'm going to use the airline. Now that doesn't look really too visible, but you can see that. And again, if I run this, I'll get another set of random airports. Actually more interesting, because this seems to be, what airport is this? So let's look at right click. That's actually, oh, an Asian, Haiku in China. Now I can change the way the graph looks like. I can actually do it, for example, and that is probably useful for airports that work with a hub and spoke layout. So do this by using a concentric layout like this. And so here we see that in this particular subset of random airports that were returned by this limit close, these Chinese airports actually at the center of all of these, and the other one are probably all Chinese or regional airport in Asia Pacific. Now, the next thing we want to do is actually show this on a map. And how can we do that? It's again very easy. Just go here and pick a different layout. Now, there are many other layouts, like grid, circular, but also the default force we've seen before, hierarchical, which is really good for showing hierarchical relationship, like bill of materials, and then geographical. So let's click at geographical. So we see a map appearing at the background, and the same graph is there, but clearly that's a Chinese airport, and that's not the right place. Why is that? Well, because we need to tell the geographical graph layout that we are using latitude and longitude and which properties they are. At the moment, by default, we highlight the airport ID, so essentially any random numeric property. In future versions, we should be able to just automatically pick up the proper property names. So if there's a property called latitude, let's use that one. If it's longitude, let's use, or Latin long, let's use that. So here, I have to do it manually. So I'm going to here say latitude, and then here I'm going to say longitude, and okay, and oh, actually it didn't. Actually, I should have automatically zoomed and panned to the proper location, but here it is. I have to do it manually. So here we see the airports that I have selected in a random way. If I do another selection, you know, I'm getting another set of airports and in different locations, because we're doing it randomly. Now let's do this in a more interesting way. Let's try and find out and run some simple queries. And for that, I'm going to go here. Sorry, not here. I'm going to go here and run a little query like this one. Well, that's the same one I did. Well, maybe I can still use that one to highlight a few things. And so go back to here. So give some names to the origin and destination like this. Instead of saying anonymous 1 is 2, now I should have something which says, okay, I should say original. Oh, I didn't do that. That's odd. It should have said this. Okay, never mind. It's the same result anyway. More interesting is doing this. Let's take this example. I want to find out, I want to look at and isolate all the flights between France and Germany. Okay, so I'm taking the IATA code, so the airport code origin, the destination airport code, the airline, on all the airports from airport origin to airport destination, from or between, actually from France to Germany. So let's run this. And so here they are. So here I see, now I see clearly the legend. So destinations and origins, because I'm going from France to Germany. If I want to do the other way around, well, then I can just turn the arrow around here. And now when I do this, I will get the reverse route, because for each route that we have, there's going to be a reverse route. So now destination is actually, did it change this? Oh, sorry, yeah, I should really also switch this. So origin airport and destination airport to be, to have the right symbology. Okay, so now these are the origins and these are destinations. Oh, come on, you didn't. No, that was correct. Sorry, I had it correctly before. I just messed up. But that's the way I can see this. Another example would be to look at look at all the flights between two airports, so Charles de Gaulle and Los Angeles and LAX. Okay, so let's do it like this. All right, so here they are. Where are they? No, they are not too many. They're actually only 4 routes. And again, there are 2 Air France routes and 2 Delta routes. I'm sorry, no, there's a Air France, Delta, and there are, oh, that's actually Alitalia. Well, so there must be a coach here. Fine. And like was shown earlier, I can now also simplify the graph by collecting. And so having just one line that shows there are 4 routes between Charles de Gaulle and Los Angeles by operating on multiple airlines. All right, so it's very easy. There's nothing to do. All you need is make sure that your vertices have got an XY column, longitude, latitude, that can be used for this. The longitude have to be long lat. They have to be GPS coordinates. So they cannot be any kind of global projection. They have to be decimal degrees in longitude and latitude. Let's go back here. So I think we talked about this when I think I showed this example of having a hub and spoke kind of organization for the airports, then switching to geographical, selecting the proper long lat columns, and then we have it this way. All right, so here again, same example we've seen before. Now this is for the demonstration here. I'm using the on-premise, if you will. So I'm running my own local graph server, and I'm using the graph visualizer that comes with the graph server. This, of course, also works very nicely with the Graph Studio. Again, all you need is make sure that in the tables you use in your ADB to feed your graph on Studio to have these 2 latitude and longitude columns. So yeah, graphs and maps are natural friends. We do have a lot of tooling available to deal with maps and spatial data. I showed you Spatial Studio. It's something I encourage you to look at as well if you deal with spatial data. It's a very easy way to analyze and work with data. And now we can also work with spatial data and maps in graphs. Try this out, give us feedback, tell us how it works for you, and any problems you hit, and we will make sure it works even better. That's it. So if there are any questions, I think I'm even ahead of time. Wow, that's interesting. So if there are any questions, feel free to pass them along.
Right, ahead of time, Albert. Yes, thank you. Oh, and there's Roger with his hat.
I had to go, but of course I'm in Texas. So yeah, I can't wear something as sophisticated as you, but you know. It'll have to do. Thank you, Albert. It was really good. I think the mixing and matching of again the geographical and graphic data is it actually adds a whole new dimension to the data and to the if you like to the understanding that you can get from it, which is just not visible if you're looking at numbers by themselves. So actually it's been a consistent theme throughout today to be able to see data visually. So I've been very interested in seeing how it's done by all of you.
And there is a question we have here about great circle routes supported.
Yes.
Now, I don't know what a great circle route is, but maybe you do, Albert.
Yes, yeah, no, Michael he's right. Actually, you know, I can maybe show quickly this thing here. He's absolutely right. Now, the routes which are shown here are straight line routes. The graph visualizer viewer, let's go with viewer, it's easier. So the graph viewer has no concept of geography as such. It will just show a straight line from point A to point B. Actually, it will still separate them. If I have multiple, it will slightly separate them to make sure that they don't overlap. That's what it does. Now, as Michael really noticed, this is not the real route. If you take a flight from Charles de Gaulle Airport to Los Angeles, that is absolutely not the route that's taken. Why is it like that? Because this is actually a projection. And maybe know about Mercator projection. This map here we see is a global Mercator projection. And Mercator is nice because it maintains angles and shapes, but doesn't maintain areas. And so therefore, there's going to be a distortion. In real life, the shortest path of the Great Circle between CDG, Paris, and Lax is going to go more like this, all the way around, all the way above, it will actually route over Greenland, all the way here, this way. That's actually the shortest route. This is not the shortest route, but that's the way Graph does. Now, Studio itself, actually, Spatial Studio, not Graph Studio. If I go back at Spatial Studio here, I think it's this one here, or this one. Yeah, notice the routes here are also not correct. Why are they not correct? I mean, they're not really the Great Circle route. If I do the same kind of thing, they go all over the North Atlantic. They really go north. That's because the route here that we're using are just 2 points. It's a straight line from A to B. And again, we're in the same projection. However, it is possible, and I've not done that here, to actually turn the routes into real curves so that follow the Great Circle and so show the more accurate routes. Now, Graph Viewer does not do that. That's another thing. So there's room for improvements in the graph viewing mechanism. And one of them, where is it? I think it's this one here. One of the things is that we could actually extend it to make it so that on the edge, on the route itself, there's also a geometry. So something that actually shows the real route of that particular object. So the real Great Circle, and then have the graph viewer show that. That will be useful also for things that are like pipes. Like Martin showed us about pipes and sewers, etc. Well, a real pipe will actually not go straight from like one place to another. It will go around a place, etc. It might be useful that we show these pipes as they are in real life, not just as straight lines. But that's future development. Right now, all we have is vertices having location, and the edges will be straight line between these two locations.
Thank you, Albert, for the very elaborate answer. That was really helpful. So